Hoffman, Everyday Spacer.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 6 a.m. on Saturday in Germany. We're broadcasting live from Thousand Oaks, California. I am thrilled to announce that this past week, I joined Zero G's referral program. Let me just read you a portion of what they sent me. Hi, Pam. Thank you for joining Zero G's referral program. We're thrilled to have you on board. As promised, your unique promo code has been created, RP-PAM. This code offers a 5% discount to any friends, family, or followers who book seats on one of our public zero-gravity flights. Direct your contacts to book directly through Zero G's website and enter the promo code at checkout to redeem your 5%. So I'm guessing it's that View Flights button, the black one down there at the bottom. And this week, I actually found some cybersecurity news, but I'm going to turn over sync jacking to Jeff because I just got somebody's random email and I don't know much about it yet. Okay. I see we have some.
Yeah,
so welcome.
Hi, Cliff.
Hi, Cliff.
Hello, Teresa.
Teresa, welcome.
Scott.
Scott. Hey, Scott.
Jeannie.
True. Yeah. Trying it out. Yeah. Hey, Dawn. Welcome.
Yeah, Janie. We're looking at blowing up the internet.
No.
Okay. Pam found something on sync jacking, which isn't really a huge cybersecurity issue, but it is something that you should be aware of, because sync jacking is someone compromises your computer, and if your phone's synced to it, then the compromise moves to your phone and then to any other computer. Now, some people are really sloppy with syncing. They sync to every single computer.
And it sounds like they sync a lot.
Right. But so if they're synced to both their home computer and their work computer, and their work computer has a whole bunch of security on it, but their home computer doesn't, then their home computer can get compromised. And now, through sync jacking, syncing to the wrong device, it gives them access to your phone, everything, camera, everything that you do on your phone.
The thing that I thought was most insidious is you can't even tell.
Right. Once you've synced to something, that's just it. So
no idea.
Be very careful syncing.
Yeah.
And
go ahead.
Look to see what you're synced to.
Okay.
I mean, that's the major thing. And most people, since it requires syncing to a compromised device, most people won't be affected by it. But if you sync to a library computer or a coffee shop computer, I mean, for one thing, why? But for another thing, you're asking for it. So just be careful with that.
I'm really glad I turned it over to you because I had no idea about any of that stuff. Yeah. I just got this random email. Well, not random. I subscribed to this person, but it just sounded like, oh boy. But, they're trying to make an offer, so they're going to sensationalize a little bit. I think, like I said, the most insidious thing to me was you won't even know it's happened. Like, I got a call today, and it started to sound suspicious, and I'm like, that's great. I'm going to go check. And I called my provider, and they said they don't really do that kind of thing. So I think it was a phishing or spamming or something.
Yeah. So I just didn't know if other people had been seeing this in addition to Pam. So I just figured I'd let people know that this isn't really a thing unless your computer's already compromised. So secure your computer first.
Not huge, but be aware.
Right. Yeah. Because this will allow people to spread the infection through their phone.
Oh.
So like I said, if you're synced, to your home computer and your work computer, they can use your phone to then jump to your work computer. And, if your security's on the work computer is good, but not perfect, well, you just, and by the way, here's the question. Is anyone's computer security perfect? The answer is no.
Well, if it's dead, it's perfect, but
yeah,
you can no
yeah.
longer
If
use
it's
it.
turned off,
It's like a lot of things. If it's dead,
Yeah.
it's perfect.
Yeah.
I saw some more comments.
Yeah. So Cliff.
Hey, Cliff, welcome. I don't know the current prices. A while back ago, it was like $5,000, I think. US dollars.
Yeah.
And we got a couple more.
Danielle.
Hey, Daniel, welcome back. The stars know everything. TV test pattern. What are the emojis? What's that say?
Gorilla fart.
Okay.
Okay.
That's good. All right. So tonight we have a crunchy topic about space weather. We'll be back in 8.3 seconds. There's a link to that book in the description. Space is big and empty. Or is it? Space weather significantly affects our space missions and us here on Earth. Once we solve the problem of getting off the Earth, space weather may be the biggest danger for space travel. It's hard to travel to other planets if the weather kills you on the way. Also, the more technologically connected we become, the more danger space weather poses to us here on Earth. We're going to learn the types of weather we can expect in space and what effects they each have on those who never venture above the sky. So, where are you starting, Jeff?
We're
sharing?
Yeah, go ahead and share.
Okay.
Because here's the wiki.
Great.
And I'm just going to start here because they talk about space weather, but they don't actually give a good definition of it.
Yeah, so, you said you didn't like it.
Yeah, I don't like it. So there are nifty pictures and stuff.
Yeah, that's a great image.
And if you want history of space weather, there you go.
Okay.
But
not exactly the definition, though.
Right. Yeah.
And real quick, Cliff says when he wins the lotto, he'll give us a call.
Yeah.
Cool.
So what is space weather? It's any variable environmental effect in space.
Okay. That makes sense.
I mean,
similar on Earth.
Yeah. And that's just it. It's like Earth. Air isn't weather, but moving air can be. Yeah. I mean, that's, anything that's variable. Oh, what does that?
Daniel says some people think space weather causes earthquakes and volcanoes and such. Well, I don't know about those, but there are some effects on the Earth from what's happening in space. Yeah.
Aurora.
And that's what we're going to talk about tonight. So.
Yeah. Yeah, it doesn't. Basically, Daniel, the only time space weather would affect the Earth is if the space weather happened to be a big rock that was coming real close to the Earth.
Well, I could think if the sun exploded, that would affect the Earth.
I mean, the moon has some tidal effects.
Yes. But
I don't know that I'd call that weather. That's just the moon goes around the Earth.
No, it's a gravity thing.
Yeah, it's a gravity thing, and it's constant, and it's so it's not variable. It's just.
Well, it isn't so far as the moon is slowly.
It's a different place.
Getting away from us.
Okay,
but it's very minor.
A centimeter a year.
Yeah.
Yeah, not a big effect.
No.
But in almost all space weather is radiation based.
Okay.
I mean, you could call micrometeorites the micrometeorite trails from comets space weather if you squirt real hard. I mean, it's kind of like.
Well, it doesn't really fit your definition.
Right. No.
Any variable environment effect in space. I can see it on your notes.
Right. I know. Well, that's just it. If you squint real hard, they go past you, so it's variable. But
so do neutrinos.
Yeah, but they don't have an effect.
No.
But so but most space weather that we think of is solar wind or coronal mass ejections or CMEs.
Yeah. Yeah, would the magnetosphere around the Earth be? Well, it's not really the weather.
No, it's not the weather. It does protect us against the space weather.
Right.
And it is, so far as the Van Allen belts are theoretically space weather as you're traveling through them. But since they're charted, they're not really weather. They're just a spot,
Yeah, I saw this on Facebook.
Show that.
This was kind of interesting. And you said this was the inspiration for tonight's episode, right?
Right. Yeah, I saw a different article, a written article.
Yeah.
That the solar storms of 2024 created 2 new radiation belts around our planet.
Which is just fascinating. And there's a whole big treatise of it here. The Secrets of the Universe is the source. Mm-hmm. And they had a whole bunch of, it's kind of long. I don't want to.
That's probably what I read, just not
okay.
in
They reference a research paper too. I really like that part.
Yeah. So you might want to send them a link to that.
All righty, I'll do that. Grab it.
Okay. But so that was my inspiration for doing space weather.
Oh, I see. We got another comment. Hold on. Let's see. Let's get that one. So that should be a clickable link in your chat.
Okay, there's Cliff.
There goes. Cliff says, I saw that there are 2 new radiation belts around Earth.
Yeah.
Because of solar activity last year. That's the weather. Oh, yeah. I saw that after I found it from that organization. And I was like, oh, cool. So you saw this too, Cliff.
Yeah.
Pretty interesting.
Yeah. And I saw something about a week and a half ago. That's what gave me the inspiration to do the space weather.
Cool. That's just fascinating. What are the implications? What does that really? I have no idea.
Yeah. And just
is it better for us? Is it worse for us? Go ahead. Sorry.
Yeah. Just like Earth, space weather is kind of location dependent. You know, you get different types of weather or different levels of weather, different places.
Like closer to the sun or.
Yeah. Since most of our space weather is sun related, closer to the sun you are, the stronger the weather. And you know, the sun constantly spews radiation of many sorts. Mm-hmm. What are we seeing here? What are they seeing? Nobody's
seeing that.
Okay.
I was just like, oh, I forgot to put this together for.
Okay.
In case you want to reference that.
Yeah, sure.
It's there. It's ready.
Yeah, that'll be good. You know, the heat can raise temperatures to lethal levels in direct sunlight if there's no atmosphere in the way. Mm-hmm. I mean, just think of the kind of shielding that they need for their spacewalks.
Okay. Yeah, even on other planets, the moon, Mars.
Yeah. So just the heat, the UV light can cause high levels of surface damage.
Okay.
You know, gamma rays, which cause, you know, damage throughout the body. And that's what generally concerns people about space weather. For one thing, you have to be careful how you shield against gamma rays. Okay. You use a bunch of metal, gamma rays can hit the metal and cause cascade radiation.
Okay. Well, they just knock electrons out of the metal and affect whatever's inside of it or whatever.
Yeah.
Okay.
Basically, it turns gamma ray radiation into ionizing radiation, which is worse for you. Yes.
Okay. Yay.
So yeah, don't use metal to shield against it.
I hear about water a lot.
Yes.
Would that have the same effect though? Because
water is really good at absorbing it.
Okay.
And you don't really cascade stuff out of water. It absorbs it really good. And if it fluoresces, it's because it absorbs so much that it's giving it off invisible light. But you have to really, really hammer water to do that. Okay.
We have a comment, and Daniel, you may want to remark on this one. In Mama's Hands, I think you're a first-time viewer, and thanks for being here. Earthquakes and volcanoes incoming. Well, not so much space weather affecting that. Let me go ahead and pull up Daniel's last thing. Yeah, it doesn't really affect earthquakes and volcanoes per se.
Yeah, now there are things that do affect that, but it mostly has to do with the movement of the core, which is an interesting topic because the core is actually changing its shape.
Oh, I hadn't heard that.
Yeah, not hugely, but it is changing its shape because it is liquid, and it could actually over time it is becoming less liquid.
Well, yeah, I mean that's how a couple of other bodies in the solar system they've cooled, so their core is no longer molten; it's solid.
Not even cooling. It's certain heavier minerals are slowly making their way down.
Really?
And that makes it, that basically brings up the melt temperature. So it helps it solidify yet higher temperatures.
Okay.
And that could kill our magnetic field.
Oh.
No, we're talking a billion years down the line. So don't worry about it too bad. whether that'll get us or whether the sun expanding in 4 billion years.
Yeah.
You know.
We got a couple more comments. Daniel says the Earth's magnetic field periodically flips, and so does the sun's, right?
Yep. In fact, the sun's, I think, just did it not too long ago.
It's in the process, I think.
Mm-hmm.
Cliff says, if a star closer than 50 light years away goes supernova, the gamma radiation would kill everything on Earth except ants and cockroaches. We've been very lucky that nothing closer has.
Mm-hmm. Yeah, and
you're very welcome.
Yeah, and the good news is most of the stuff that's anywhere nearby is not the kind of stars that'll go supernova.
Okay.
And I'd have to look that up, but to see how far away any of those candidates really are. But that'd be interesting to.
I'm just thinking back to what I made at the.
Okay. Yeah. So you've seen the same stuff I have. I just don't.
Why isn't share? I'm trying to share.
Maybe I'll try sharing that.
Huh.
His doesn't want to share.
Oh, fun.
Oh, it is there. Oh, you were just your screen was frozen.
Yeah, these new computers, I think, are. Anyway.
Okay. But
we got to do workarounds.
Yeah.
At least that's what I've been finding.
The computers are faster, therefore it's glitchier. I don't know.
Yay.
But
Betelgeuse?
No, Beetlejuice.
I know, but it's spelled okay.
Yeah.
Beetlejuice
is actually fairly far away.
And is it one of those candidates?
It is. Oh, definitely
okay.
It is big enough.
I don't know for sure.
Okay,
big enough. Yeah.
Yeah, the bigger this
part of it's big. Yeah.
Yeah. Well, and that just shows that it's getting close too.
Well, and my glitchy thing isn't helping, so yeah.
Yeah.
Faster internet would be wonderful for all of us, wouldn't it?
Yeah.
Sorry, go ahead.
That's fine. So the Van Allen belts, which we mentioned, is actually a product of solar radiation.
Okay.
Because it captures charged particles from the sun. So the radiation of the Van Allen belts.
I'm not entirely sure what the Van Allen belts actually
It's regions in our magnetic field that kind of have trapped stuff.
And it's kind of dangerous for like when people launch to go through it, right? Through it?
Right.
Through
Yeah.
It? Okay.
Not a huge. Oh yeah. Yeah.
We got to get him on the show and have him tell us about it.
Yep.
Hint, hint.
Yes.
Nudge, nudge, wink, wink.
But
what's the rest of that?
Well, and that's where the two new belts, from the recent solar radiation.
So there's more layers that have captured more material that's been.
Yeah.
Okay.
And it's not.
Does it make it worse?
Well, it gives more. Yeah, it gives more areas to be in it.
Okay.
And it's not like if you're launching a rocket through it, it's not that bad. It's kind of like getting an X-ray.
Okay.
It's if you have an orbit that sits in it, that'd be not good.
Okay.
And some mid-orbit satellites kind of are right there, mostly because the Van Allen belt isn't like the same distance everywhere. So it's kind of a little bit variable.
I did live there for a while. There's words at the end. I just can't remember what they are, though.
Yeah, but it's not like you even like that show.
It's complicated. Go ahead. Basically, geometric radiation, very hot.
Yep.
I think it can be, yeah.
Yeah.
Of course, if there's not very many molecules out there to heat up.
Here's the difference between heat and temperature.
Which we did an episode.
Yeah, we talked about that once. So we'll just since you might not have seen that episode, something can have really high temperature but have very low heat. And we saw it like aerogel. They heated it up to the point where it's glowing. It's like, really, really hot, but you can hold it in your hand, or its temperature is really high, but you can hold it in your hand because it has very little heat. There's very little heat to transfer to your hand.
Very fascinating, actually.
Yeah. So temperature doesn't matter as much as heat. And So even though, you know, Van Allen belt has a pretty high temperature, it's so diffuse that it doesn't matter that much to you.
Okay.
And okay, if you spend all your time in it, you would slowly heat up.
Okay.
But, you know, not.
Sounds like a microwave.
Yeah, but the radiation would get you before the heat would.
Okay.
So it doesn't,
Yay.
you know, it doesn't really matter that much.
Okay.
But, you know, so the Earth's magnetic field isn't really radiation except for certain zones of it, like that have captured solar radiation.
Okay.
Oh,
Rely on. I'm a little confused. Daniel says heat is related to thermal mass more than temperature.
except that, here's the weird thing, Daniel, is that heat will transfer from one thing to another until their temperatures are equal. So that's the weird, you know, that's the weird link between temperature and heat. So it will only transfer until the temperatures are equal. So, yeah.
And we got a yes.
Yeah.
Got it. Okay.
So, you know, our geomagnetic field isn't really that strong. It isn't really weather except when you're going through the belts.
Okay.
Now, Jupiter, on the other hand, that has a magnetic field that is very dangerous.
Yeah.
To the point where your brain will glitch out if you're not shielded and you get too close to it.
Okay.
And could have, you know, other effects.
And I know they talk about like when the spaceships circle out, they have to come in to do their research and capture their images and stuff, and then they go back to get away from the radiation.
And it's not like going out fixes anything. It doesn't go away from the ship. No. It's just anytime it's in the radiation field, it's taking damage. Yeah. So that's why they loop in and get back out so that they maximize their mission, but minimize the damage so that they can keep doing that as long as possible. But eventually it will glitch out from the radiation.
But this is just a strategy to...
Right. But it means that, us getting anywhere near Jupiter is going to be interesting. It would take a lot of spaceship to keep us safe. Or maybe make our own magnetic field around the spaceship.
Could we change our basic components like DNA and become something different?
You could, but okay, you could let's say you upload your brain into a computer.
Okay.
Computer's even more vulnerable to that stuff than we are. So I don't know that win you anything.
Okay. Well, even biologically, I mean, just...
Yeah, I mean, they're theoretical tweaks.
Radiation hardened creature.
Right. Now, what else would that cause? Don't know. I mean,
save the electronics. Especially the memory. Okay. Yep.
Yeah.
Thank you, Cliff.
I wonder if they do any error correction in the memory when it's away from Jupiter.
I don't know.
If I had the processing capacity, I'd do CRC checks on the memory as on the way back out.
CRC being?
I don't remember exactly what it stands for, but it's a little code at the end of every bit of data that you do math on the data and it gives you the code.
Okay.
So if you do the math on the data again and it doesn't match the code, something's wrong with the data.
Okay, that's helpful. Thank you.
Yeah, and also
so the CRC stands for something most likely.
Yeah. Cyclic redundancy check. There you go, Daniel.
That's why we love you. Yeah. CRC is cyclic redundancy check.
Yeah, and the other kind of checking.
Space it is radioactive as Chernobyl. Oh, that's a good question. And welcome. Thank you. I don't know how you say that.
The sun.
OB.
The sun is more radioactive than Chernobyl. It's a different kind of radiation. I mean, it's
fusion
instead of fission.
Yes.
But it's still putting out heck of a lot more gamma rays than Chernobyl.
Hmm.
That
It's
the
also very
bad thing
far away.
about the thing that makes Chernobyl so dangerous is that you can get close enough to it to die by radiation instead of being burned to a crisp.
From the sun.
Yeah.
Okay. Got it.
Yeah. I mean, the sun you just burn to a crisp before you get really that close. So
Okay. Great question though. Thank you.
yes, so Chernobyl is actually safer than the sun because you can get close enough to it to die by radiation.
Okay. What? Okay.
It's also harder to see Chernobyl, so it's safer because you can't see it. You see.
Okay. What else you got?
The last type of radiation, which isn't really weather because it's kind of constant, is cosmic radiation. Daniel just said it.
Right on. Thanks, Daniel.
They're actually not necessarily the worst, Daniel. It's fairly constant, and that does shorten the amount of time that you can spend in space. But what comes off of the sun is actually stronger and worse. Most galactic cosmic rays are in the form of neutrinos and other stuff like that.
Neutrinos don't care.
Yeah, and that just doesn't affect us that much.
We don't care about them either.
Yeah, it doesn't affect us that much. There's a lot of stuff in the galactic cosmic ray stuff, and that's why I don't consider it weather, because my definition is that it's an effect. It's a variable environmental effect, and a lot of the galactic stuff doesn't affect us. Now, I do have down a little bit further that it does that you do get other types of cosmic radiation once you get past the heliosphere.
Yes.
But we're a long ways away from that. I mean, both distance and being able to get there. I mean, we've only got 2 vehicles that have crossed it so far.
And they were launched in the 70s. I got a couple comments. You ready?
Okay, yeah.
So Cliff says, and thanks for waiting, you can get tours at Chernobyl.
Yeah. You just don't get too close to the really hot spots.
They might actually give you some hazmat stuff too. And in Mama's Hand says, what do you think about 500,000 mile solar opening from the sun? Any reactions? I don't even know what that means. Do you know what that means?
Are you talking about one of the black spots on the sun where it occasionally? Now, here's the thing about those. Those are caused by the magnetic fields, because the magnetic fields in the sun kind of sometimes loop out of the sun itself. And
they usually loop right back in.
Right. Usually loop right back in. So they're usually not that big of a problem. But sometimes the loop kind of twists off and breaks. And that's where you get a coronal mass ejection.
CME for short.
Yeah. So.
Oh, okay. Thank you for clarifying. Yes, solar winds, maybe.
Yeah. So.
Okay. Very good.
Any of those holes are actually places where you get a lot more solar wind coming from it. So that's what makes the solar wind a variable, because the sun's always changing. And being able to predict stuff like that, like spotting it not pointed at you, but knowing that it's coming your way, is one of the things that, and just like you predict Earth weather, you can predict solar weather to a degree. Cosmic rays, most of that doesn't affect us, but as Cliff mentioned, a supernova nearby would be bad. There are other things that can be bad. Technically, the gravity waves from 2 black holes hitting each other are solar weather. It's just that we're not big enough or fragile enough for it to bother us. But you get past the heliosphere, and that's a whole nother can of worms that we just don't know enough about. Just figure that there's got to be more stuff out there.
Well, that's why we sent the Voyagers. And I must apologize because I see a comment that I completely missed, and I don't know how. It's Jupiter Scary. Yes. Thank you. And thank you for waiting. Oh, and we got something new here. We'll see if I missed anything else. Yeah, but I don't know if I missed anything.
No.
There was one that was quarter of the sun, the last solar cycle.
Yeah. A hole. Yeah.
Oh, okay.
Yeah.
You want to comment on that, or should I go?
Well, and here on Earth, not that big of a deal, except that that sends not a lot of stuff to us, we could have another Carrington event where it hits the magnetic field and just basically rings us like a bell and causes bad things to happen to our power lines and stuff like that.
Did it overwhelm or just shut them down? Or
no, because the power lines act like an antenna and pick it up like you would pick up a radio signal. It just causes voltage on the power lines that isn't supposed to be there, and can be a really high voltage and can burn out stuff. You know, yeah, it can cause really bad things, especially since everything's connected by power lines nowadays.
Yeah.
I mean, a lot more than than historically happened. So it could have a really big effect of just blowing out transformers, blowing out relays, switches, electronics. You know,
yeah, and the more
it's kind of like getting EMP'd.
And the more stuff we have and the more complicated it is, I think the more vulnerable it can be.
Well, yeah, the higher tech you get, kind of the more fragile this stuff is for that sort of thing.
So let me go ahead and do. And thanks for waiting, folks. Again, we're getting a lot of comments. Wonderful. We love that. We really appreciate you being here. What happens if a high energy proton hits a satellite? Is it like an EMP?
Good
question.
One, not really. I mean, to be perfectly honest, it's not that damaging. Now, a whole bunch of them could. I mean, if the proton hits something that's extremely vulnerable to it, you could have like the magic bullet issue where it just hit just the right spot, but you'd have to get a bunch of them to cause enough of an effect.
Okay.
And that's why the density, you have to have a lot of density for that sort of thing.
Okay. And Superman is here. We're glad you're here. Welcome. Thanks. Have you ever seen any anomalous things in the sky? Interesting you should mention that because, well, stick around. We're going to do more about that next week. And yes, I have. Absolutely.
Yep.
And Mama's hand says, okay, thank you. Cliff says, yeah, it wasn't pointed our way, but it was huge. I saw it. Even satellites would be affected. Absolutely.
Oh, yes. Oh, yeah.
Absolutely.
In fact, the solar wind affects the low satellites in another way. It makes the upper layers of our atmosphere hotter, and it expands the atmosphere, which causes more drag on the satellites, which means that they have to spend more fuel staying up, which shortens their lifespan. Yeah. You know, so
because once they're out of fuel,
they'll eventually auger in. Because here's the thing: our atmosphere doesn't stop at a line; it just gets thinner and thinner and thinner. So it's always dragging on the satellites, and that's how they plan their lifespan for the low Earth ones.
Okay.
And anything that blows up the atmosphere, inflates it, shortens their lifespan because it makes it, so yeah.
Got it.
Let's see. So what can we do about space weather? We can predict it. And there are various things.
Oh, is that where this thing comes in?
Yeah.
This one? Okay, let me go ahead and,
because
there's a really cool website called spaceweather.com, and they have things like this daily sun, and that's part of the predicting part. Go ahead.
Yeah. And this is a good site. And I've got some others too, because I've got NASA and ESA sites that essentially do the same sort of thing. So I'll show those once you've looked through this one.
Yeah, that's good enough. And I can grab it and give people, it's just spaceweather.com, but let's go ahead and make it a clickable link in the chat for you. And I got another comment.
Okay.
If you're ready for that.
Sure.
Let me let that settle a second, because it just keeps bouncing around. So, all right. So let's see. Hence why the lower states saw aurora last year.
Yes.
Yeah.
Yeah. The stronger the solar wind is, the more aurora you see. And theoretically, you get auroras all over the globe, but they're so faint because they're so low energy that you just can't see them.
In the daytime, you can't see them.
Right. Yeah.
Actually, there's an aurora predicting site, kind of like the space weather one was. I didn't find that though before the show started. Sorry. Daniel's got something. At 1,010 Teslas, the hydrogen atom becomes 200 times as narrow as its normal diameter. Magnetar level stuff.
Yeah.
Interesting. Oh, 10. Oh, 10 to the power of 10. Thank you. Oh, and in Mama's Hand says, I saw it in here, Colorado, for the first time in 20 years. Oh,
yep.
Amazing. Yeah, we went looking, but we're in Southern California. No dice.
Too much light pollution here for us to
That's
really
part of
see
it, yeah. Since Mars is farther away from the sun, how would that affect solar panels that are on Mars? Ooh, really good question. Lots of good questions.
Yeah, solar panels aren't that effective. I forget the percentage, but it's like a small fraction of the usefulness that they are on Earth. So you need a lot more solar panel to get the same amount of light, which is which is what eventually did in some of our early rovers, and that they used solar panels and they got covered in dust. And they actually overbuilt the solar panels so that they could be partially covered in dust and still operate.
And the winds actually helped with it.
Yeah, the winds. But our latest ones, we sent mini nuke generators on them, so they were totally independent of solar panels.
Got it. Cliff says, I saw aurora here in Pomona. That's Pomona, Australia, folks. At 26 degrees latitude. Unbelievable. And the aurora down there are much more intense than the aurora in the north.
Right.
It's almost a cyclical like the weather in the almanac.
Yeah.
Talking about the aurora.
Yeah.
Yeah.
The sun has an 11-year cycle and a 22-year cycle. And yeah, and it is a cycle. It's not exactly the same. It's kind of like Mark Twain said, history doesn't repeat, but it does rhyme a lot. So that, in the cycles, there's similar things happen.
Mm-hmm. All right. And so we have, I wonder if wind turbines would work better on Mars than solar. Not as much wind either as here.
Well, no, the wind is actually, it's faster, but it's not pushing as much air. And here's the one problem that I had with the movie The Martian. The solar wind is not strong enough to blow anything over. You would barely feel anything about it because there's so little air moving at you.
Like the number of molecules in a
right
cubic,
whatever,
right, anything.
Yeah. So the strongest wind, probably about the equivalent of that.
Well, they did say something recently that they might be more intense than we expected, but still not. It's still not going to be anywhere near Earth.
Yeah.
Because there's a lot of molecules in the air, for one thing.
Yeah. Yeah. So
yes, it was a great movie.
Yeah, The Martian was a great movie. Once you got past the wind, I mean, it was a great movie.
Don't forget the potatoes too.
Well, okay. And
there were a few problems with it, but suspend your sense of reality, and it's a great movie.
And just so you know,
don't deal with physics.
Yeah. In fact, I saw a whole.
You're very welcome.
Yeah, I saw a whole talk on what you'd have to do to pull the poisons out of the Martian soil, because the Martian soil, you can grow potatoes in them just fine. The potatoes would leach the poisons out and kill you if you ate them.
Far out.
Yeah. So you need to have a fungus, which is what they're looking at, to eat the percolates that are in the soil and convert them to something else.
That was ISDC, wasn't it, last year?
ISDC. Yeah, there was a really good talk on that.
Yeah, a lot of really good talks.
So yeah, so yes, he could have grown the potatoes, but they would have killed him. In fact, if you find a site called Cody's Lab, he actually went through a lot of those things of like, would the low air pressure kill the potatoes? With the cold, would they, so he basically did tests with vacuum chambers and,
I think we watched some of that.
Yeah. And basically did the tests on whether, the potatoes would survive. And he showed that, a good chunk of them do survive. So, that part was pretty good. I mean, the wind just makes me twitch, but it's not that bad.
How about this then? Well, it does go global on Mars, and it buried a rover. I did not know that. Oh, I used to love Cody's lab until I found out he was liberal. Oh boy, I don't think science cares.
Yeah, I don't care about his politics. He does decent
No.
science, though.
You know, that's a personal problem.
Yeah.
Whichever way you think of that. Oh, it was a movie. Which movie?
Oh, no, he's just.
Oh.
Oh.
Okay. Potatoes are so finicky? What? Really? I've never grown potatoes.
Well.
Okay, good to know. He's cool. Cody's lamb is cool.
Yeah.
Yeah, just look at the science.
Yeah, just
don't worry about anything else.
Yep.
You know, everybody's on a spectrum for every single thing you could possibly think of. Everything.
Although that spectrum seems to be spinning, and people are like sliding out to the two ends of the spectrum. But hey,
kind of too bad. Okay, Mars receives only about 43% of the sunlight that reaches Earth due to its greater distance from the sun. That is very helpful, Daniel. Yeah. Thank you for looking that up. And
one of the nice things is that the atmosphere that will kill you because there isn't much of it doesn't block as much of the sunlight either. So,
far out.
You know, so
you win some, you lose some.
Yeah. So the solar panels would work better than here, except that they don't get as much sun.
Got it. Have Starlink. That is cool.
Yeah.
Colorado, we grow them 10 degrees, too cold or too hot. They are done. Interesting. I did not know that.
Yeah, but I think Cody's lab showed that enough of them survived that he could have, you know.
They grow anywhere you plant them.
Yeah.
I bet not anywhere.
Yeah, but the thing is that I don't know what your real name is in Mama's hands, but his potatoes didn't get that temperature in a sustained period. He didn't have that they didn't have that temperature for days. It was just a brief time, and that's what he tested against. You know, so he didn't test an overnight of that kind of thing. He tested for what they said happened in the movie. So, but you know, so predicting solar weather, you know, as Pam showed on hers, and both NASA and ESA, European Space Agency, have sites that shows.
You got those, right?
Solar, yeah. So let me.
When you're ready.
To them.
He has a lot of tabs.
Yeah, I have a lot of them. Okay, so
you ready?
Go ahead. Yeah.
All right. This is
Space Weather Prediction Center, and
bigify that.
Oh yeah, here.
That's
and they have lots of links. And the homepage has pretty pictures, like the space. And if you notice, the space weather site is cribbing off of.
Oh, Raw Forecast. That might be the one I was thinking of.
Yeah, and space weather is cribbing off of this probably. NASA and NOAA. The sun has reached the solar maximum period.
Yeah, they don't really know that till it's kind of over.
Right. Yeah.
The cliff says they grow millions of tons every year, and it's hot, dry floods. They are pretty tough.
Yeah.
I don't think you can grow them in rocks though, or sulfuric acid, or stuff like that.
This is ESA's site.
That's cool.
Yeah, and so they've got a slightly different take on it. You notice they have pictures of Europe instead of the U.S.
Naturally.
Shocker, but so a lot of the same information that's just formatted differently. But you know, that's they're both good sites. Off of the NASA one, we have a 3-day forecast. So they can, this is essentially the various things, geomagnetic storms expected. And, you know, so this is what you could use to predict it. And I have another one here that just shows the different types and effects of, this is heliophysics observatory system. And so this is what they're using to predict the space weather.
Oh, cool. That's neat. I got a bunch of comments when you're ready.
Yeah. Parker Solar Probe is like the earliest one, Solar Orbiter. then okay, go ahead.
Oh, let's see. So we were having a solar flare not too long back, and I was looking at space weather, and it did not have any info about it, and it made me sad because I thought that is what they were there for. I don't. And you like Soho? That is a cool satellite. I don't know, but once upon a time they were pretty up on things. So if that's changed, I don't really know about it. We mainly call them spuds. Yep, we do too. Daniel says, I hope they don't doge the Space Weather Prediction Center. That would be unfortunate. Cliff, we are high altitude. Maybe that makes a difference. Okay.
Yeah.
Good observation there.
But would make your conditions closer to Mars. I mean, not significantly closer, given that, Mars's atmosphere is.
Oh, we did an episode on the Space Force, and that's been around for 70 years. His first term, Trump just made it happen.
Yeah, it's been
know that.
in creation for a long time.
Yeah.
But okay, so
and I think it's going to be very important to us.
Yeah. So here's a nice one about space weather. Of this comes from the sun. Various things that cause the space weather on the sun.
Boy, that's a good one.
And basically, if we're on Earth, we see it mostly as aurora, but we could get other effects here. But it's when you're out in space that it really matters.
Yeah. Got some more. 12,000. That's pretty high in Mama's hands. Yeah, that's pretty high.
Yeah.
I'm not sure what you're referring to. Do you know what he's saying? Maybe. Water.
Probably the potatoes.
Oh, okay. Galactic Greg Allison just did a great video about the danger of the Chinese getting a moon base and launching rods of God from a mass driver. Yeah, there's a couple of different problems with the Chinese getting a moon base, because they could have a very small, center of operations, but claim that they have to have a lot of space because of their experiments, and thereby claiming parts of the moon, which,
yeah. Well, we have treaties saying that no country can actually claim the moon, but
China doesn't.
Yeah, when have those treaties bothered China at all?
No, and thanks Daniel for Greg Allison's. I know Greg Allison. He's that'd be very interesting to watch.
Yeah.
About the Chinese. Yeah.
Yeah. So again, here's another one. Solar flares, coronal mass ejections, solar wind, which is kind of almost constant, although it fluctuates, and our Earth's magnetic field, which basically bends this radiation around us. So, but that's all I've got to show. I've got other stuff, but that's
okay.
What I had to show.
So, Venus and Mars aren't always in the sky, always being the key factor. But they can look bright. Mars sometimes doesn't as much. Right now, Venus is like -4.2. Apparently,
yeah, it's pretty.
Apparently, it causes shadow. I didn't know that. But anyway, yes, friends about it, and they always think it's a satellite. You can see a satellite, and it moves a little different than any planets.
Any satellite that's bright enough for us to see is visibly moving.
Right, and it's not moving like a plane or anything else. It's kind of a unique.
And satellites don't flash, so you can tell. You can tell a plane from a satellite pretty easily.
Right, and they move. Planes move really fast by comparison. It's all kinds of different things out there, and we get all kinds of different reactions. So, it's again a spectrum. Some people know stuff, and some people know nothing, and there's various reactions to all kinds of stuff. All right, so let's see. They all have bases on the moon for sure, just like Antarctica. I don't think the Chinese have a base yet on the moon. I wonder what would happen if our magnetic pole flipped. Yeah, we were talking about that before. I mean, I think it has.
I think navigation will be screwed up, although luckily we're more to GPS than compasses. But that could mess up migratory birds. But the thing is that it won't wipe them out because it hasn't in the past. Because it flips about every 10,000 years.
Oh, okay. It has in the past, and there is always a new epoch of life and death.
Yeah.
Oh, okay.
Yeah.
Interesting.
I think it's the period of the change when the magnetic field kind of lets more radiation hit the ground.
Oh, interesting. Okay.
So that'd be, that'd be the bad part. Is that it's the changeover.
Oh, thank you, Daniel. Appreciate that. That's nice of you.
So,
okay. Well, did you say you have other stuff?
Yeah. Here, let me get to. Oh, go ahead.
Oh, okay. So, solar wind sounds cool, but not like Earth wind because that is air. What is solar wind compared to Earth wind? Very good question. I like that. He says, right, Jeff. Whoops.
Yeah.
I skipped one. Sorry. Cliff says, right, Jeff. And in Mama's hands, isn't it curly in Siberia? No.
I don't think so.
I think they're just off of. They're usually just off of.
I thought it was.
What's the other one called?
Okay, I haven't been paying too much attention, but the last time I saw it, it was near Finland. But it could be in the magnetic pole. No, it's been traveling. It's been traveling. All right. A few miles a year.
I thought they were very close to.
No, not anymore.
Not anymore. Okay.
Yeah,
I don't know that.
When we were kids, yeah, they were really close.
Oh, interesting.
But
yeah, and I don't know when the 10,000 year cycle comes due.
And I don't know that it's exactly 10,000 years. Just it's a round number, and plus they don't have extremely precise records.
Cliff says it's moved very recently.
Yep.
Okay.
Yeah.
You always make it a better show, people.
Yep.
Keep commenting. We love it.
Yeah. So what can you do about space weather? That's there was a question about what is it?
Oh, this one
compared to Earth wind. The sun is always, essentially there's stuff on the surface of the sun is evaporating off and being pushed off by the radiation of the sun. So you've got a combination of light, gamma rays, and like ions, hydrogen and helium ions that are just pushed off of the sun.
Okay.
And that's what the solar wind is. Now the ions themselves are charged particles. That's what makes our auroras. Those are fairly easy to shield against. Not like the current stuff that we have up there gives a little bit of protection against them, but it's not, but it doesn't give a lot of protection, which is why, if there's a big solar wind event, that's actually concerning. And what's the,
I gotta go back up a little bit.
with that one.
I thought this one.
Oh.
Daniel says Earth's magnetic pole flows about every 200,000 years.
Oh, could be.
Okay.
I don't know enough. I remember 10,000, but if you looked it up, I'll go with the 20,000 because my memory is not what it ever was.
My RV is EMP proof because it does not have a computer. A 76 Dodge RV with 360 and 727 torque flight trans. Okay. Thank you. You guys are great. Oh, thank you. Aw. Yeah, and we just love looking up, digging, that kind of thing. I don't know what this is about. Oh, no. Okay, so try a different term because I need something else here, I think. The sunspot, yep, every 11 years. What about solar flares? Are they a real risk? Absolutely. That's what the Carrington event was about.
Right, yeah. Well, it was a CME, which, but yeah.
Yep, we overdue. I think the sun's poles. Is that what you're talking about, Cliff?
Yeah. The sun's magnetic
poles,
yeah.
Like either in the process of flipping or something.
Yeah. Yeah.
I think we've done some episodes on a couple of those different things. Absolutely look for previous episodes. If you got a term you want to look into, you can do a search.
Yeah.
And that's how I find things on my own channel.
Yeah. And Tim, solar flares are definitely a threat. If you can think of a coronal mass ejection as like a super solar flare, not quite, but it's in the same realm of things. And that's what really is going to kill technology if that hits us.
That's really funny because Tim, I didn't realize that was your first comment, and welcome. Thanks for being here. I think it's maybe your first visit as well.
Yeah.
Very cool. Okay, so I'm not a her, but I do like some of the stuff they say. How about how stuff about space seems fake, but I like to learn the truth. Yeah.
Here's what makes.
I ask him, what the heck? Oh, that's funny. I thought I was doing often because there's cliff in between. All right, so Yellowstone. What? Oh, yeah, Yellowstone.
Yeah, Yellowstone might. Note that Cliff's about the only one on here right now, I think, that won't be affected by Yellowstone much.
Maybe, yeah.
Because it'll definitely have a big effect on Northern Hemisphere.
Well, they're just talking to themselves now. That's a keeper, all right. And Bob Scott, thanks for being here. Welcome.
Yeah.
Lively crowd tonight. Thank you so much. This is wonderful.
So, what can you do about space weather? Generally, shield against it.
Okay.
But the more you shield, the heavier your vehicle is in space, and the more energy it's everywhere.
Yeah.
So it becomes a losing proposition.
You do stuff on Earth, though.
Yeah. So one of the things that they're talking about is creating a bunker in the space station or in the vehicle, creating a bunker in the vehicle where everyone can gather in this one small area that's shielded. And that's why predicting is so important. And that's why they're really working on predicting space weather, because if we get out there, we're going to need this. So instead of having to shield the entire vehicle, which you still do want some shielding around the vehicle, just because you've always got solar wind, you've always got cosmic radiation. So it's always going to be there. So you want to shield against the light stuff, but maybe have a bunker like, that you shield so that you shield a smaller area, not too comfortable to be in, but you don't have to be in there very long.
Like a panic room?
Yeah, like a panic room.
Okay.
You stuff people in there like sardines and they're there for a few hours, or worst case scenario, a day or two. But that's usually not best case scenario there. But one of the things that they've shown is that metal is not a great way of shielding against it, because yes, it will stop a lot of that stuff. Unfortunately, metal will cascade stuff. Like say gamma ray comes in and hits steel, or a cosmic ray actually can turn cosmic rays that won't bother you too much into really bad stuff, because it'll hit the metal and basically shotgun out more radiation out of the metal from the impact.
Yeah.
So
you were saying that before. So
water is a very good protection. For one thing, we need to carry water with us. So, why not use it?
Potable after that, though? I don't know.
Yes.
It is. Okay.
Yeah.
And Daniel says, if you have enough energy available, you can do interesting shielding with electromagnetics or even plasma.
Yes. The shielding will protect you against the ionizing radiation, and will, against the ions and stuff. Will not protect you against gamma rays.
Oh. Okay.
Because they're photons.
Okay. What do we do on Earth?
Well, we have dense atmosphere that by the time they get down to the Earth,
just a massive amount of molecules between here.
Yeah. Okay. Yeah, it's just mass is what's protecting us.
Cliff, 36 hours in the airport.
Yeah.
That was last year.
Yeah. But imagine, Cliff, if you had to be in a little room with 4 other people. But
even X-rays are photons.
Yes. From gamma ray to radio wave, and visible light is somewhere in the middle of that.
Nothing can shield gamma rays.
Yes, you can. You just mass. The more mass you have, the more chance you have of stopping a gamma ray.
Okay.
That's like lead.
So take a moon around with you.
Or lead works really good. You really don't want to try to move a spaceship that has 6 inches of lead
gathered out there.
Yeah, around the edges.
You go out to the asteroid field and you pick up some things here and there. And 8 feet of lead.
Yes, there you go.
My goodness.
There you go. That'll protect you.
Yeah. Yeah, you really should pick it up out there then.
Yeah, but yeah, good luck moving it too, which is why
I think it's getting it going.
Yeah,
yeah, maybe the moon.
yeah,
Cliff's on my side. Yeah.
yeah. So the more mass you have around you, now water works just proportionally well against it. So the water is actually a really good thing. Now I saw a thing again at the ISDC where they were talking about storing the water around the skin of the spaceship, which was nice, except that they had like 1.5 to 2 inches of water around it. That's not enough. I mean, okay, it's enough for if there isn't a big solar flare, but you know, if you're going to Mars and it's taking you 6 to 9 months, yeah, you're going to get roasted at some point. So that's why you want a bunker.
Ooh, that's interesting. Every centimeter of lead cuts the gamma rays in half.
Yeah. Yeah.
Wow.
Yeah. Which is, lead's pretty effective. Water's effective, and you can drink it.
You can drink it, yeah.
So their system was, you have alternating tubes with potable water and wastewater, and they also had something to to clean the water in between, so that turning the wastewater back into potable water. So they wanted a closed system. Again, it's not thick enough to do much. You would still want a bunker in that. Otherwise, you can get toasted just by having a bad day. It becomes a gamble getting anywhere then.
Depends on the strength of the radiation.
Yep. Yeah, you cut it in half, and half of a lot is still a lot, but so that's why water.
Okay.
And there are other things that actually block radiation better, but they're again even heavier than lead. Speaking of radiation and water, XKDC, if you've ever seen that site, someone asked him a question, and he has a what if site about, they store nuclear waste in pools of water. And what would happen if someone fell in that water? And turns out that anywhere farther than about 6 feet away from the actual nuclear waste in the water, you actually get less radiation than you do standing outside of the water, because the water is actually blocking the radiation from the sun too. So 6 inches down to 6 feet away from the nuclear waste has lower radiation than you get just by standing in the sunlight.
That's bizarre, but that's what they're known for over there.
Yeah. So, and he calculated it out. But so water is really good for that. But again, if you have a water tank, make it hollow and you can ride it out. Yeah.
Ray.
Oh. Yeah. The gamma rays. Yeah. Just the more of them there are, the more lead you have to have a safe level. That's all.
Well, that's the interesting thing about space travel. Lots of cool problems to solve.
Yeah, which is why I want to get on the moon. And then you can toss stuff off of the moon a whole lot cheaper than you can toss it off of here.
Oh, yeah. Oh, we got another one. Water exposed to gamma ray does become radioactive, but it isn't very much. And the radioactive isotopes decay away fairly quickly.
Yeah.
Good to know.
Yeah.
Thank you, Daniel. What else you got for us? Anything?
Let's see. Talked about the bunkers. I think that's it. Unless other people have stuff.
Yeah, we'll keep watching for comments, but I'm going to go ahead and talk about some solar events this week. We're talking about February 21st tonight through February 28th. Next Friday, the Globe at Night continues its project and runs for 10 days total. This month, the Citizen Science Project runs through the end of the month, February 28th. You're looking for Orion. If you're in the Southern Hemisphere, you are also able to look at Canis Major. So they describe how this works in 6 easy steps. They say 6 easy star hunting steps for you to help them understand what you are seeing from your location. It's easy and fun.
Oh, here.
That's globeatnight.com, I think it is.
Dawn.
Oh, yeah. Oh. I think so too. Thanks, Dawn. February 21st, Antares is 0.4 degrees north of the moon. They didn't say an occultation for that one, did they?
No, they didn't.
But it's awful close. February 22nd, the moon runs low. February 24th, Mars is, well, they say is stationary, but it appears stationary. February 25th, Mercury and Saturn are in conjunction. Mercury is actually 1.4 degrees north of Saturn. Oh, we got another one, Danny.
Yeah. Thanks, Space Weather Team. Hope your National Caregivers Day was
that
great.
Today, National Caregivers Day?
Yeah. Blessings, everyone.
Blessings to you too, Janie. Let's see, on the 25th as well, Pluto and the moon are in conjunction. You're going to need binoculars for one of those. February 27th is the new moon.
You're going to need a really big telescope for one of them.
Right. And Venus appears stationary. The 28th is a busy night. Mercury and the moon are in conjunction. Mercury is 0.4 degrees north of the moon. They did talk about an occultation, which is visible from Australia, Papua New Guinea, and eastern Indonesia. So there you go.
Yeah, this is
Cliff. It's going to be wet and rainy that day.
Yeah, this is the first time they've talked about occultations that wasn't North America.
Ah, yeah.
In the 2.5, 3 years that we've had that calendar.
Yeah,
that's interesting.
Saturn,
maybe they're starting to do that.
That'd be great. Saturn and the moon are in conjunction. Ramadan begins at sundown. Also on February 20th is our Friday night show, and this goes back to one of the comments. I'm going to do something loosely related to space weather. You'll find out about that shortly. So, as Cliff says, it's still raining. What'd you buy? So find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. What inspires you the most for the coming week?
Yeah. Cliff, if you could give it to us, we would take it.
Yeah. I think we're going to go right there. Go ahead.
Okay. So if you or someone you know has done something interesting involving space exploration, science, or astronomy, we'd love to share our live. Join us again next Friday, February 28th. Sky Phenomenons, Sundogs and Glories.
And there's some other things too. I forget what they're called,
like
though.
Green flashes and stuff like that.
Yeah, right. It's going to be more aesthetic.
So it's sky stuff.
But yeah, it's going to be related to space weather.
Yeah.
I'm going to talk more about pretty pictures for you. Another 5D camera. Oh, jeez. Sorry, man. All right, so thank you so much for being here, folks. We really appreciate it. Cliff was here. Janie was here. Dawn, Daniel. We had some new people. We had a lot of new people.
Yeah. I'm just trying to figure out what a fifth dimensional camera looks like.
Bob Scott was here. And I don't know how to say this. Oh, baby. Yeah, Mama's Hands was here. Tim Trapman? I said Daniel. Did I say Daniel? Yeah. Daniel was here. We got that one. Scott was here. I know Scott was here. Janie was here.
Did you say Dawn?
Dawn was here. If I don't, we can say it again. Whatever. It works. There's a lot of comments. Thank you so much. Again, it is always a better show when you are here to ask your questions, to look up things on our behalf, and just generally hang with us.
Yep. Really
appreciate that.
Oh, Superman.
Superman is here.
Yeah. Oh, and Cliff says it's the same camera, same as the one he had over here.
Okay. I'm still scrolling.
Yes.
I think we got pretty much everybody though, right?
Yep. Yeah, I think so. Oh, TV test pattern.
TV test pattern.
Oh, and Teresa.
Teresa Beach Cooker. Thanks so much, folks. We really appreciate that. Have a really great week.
Yep.
It's going to be the end of February next time. Yeah. Yep. We'll have fun.
Yep.
Talk about really cool, beautiful looking things. That's the nice thing about this. We have some really, really beautiful imagery for you to share.
Yep.
Oh, thank you, Cliff.
Yeah, thanks, Cliff.
Well, we're here for you.
Yep.
All right, folks. Have a good one. We'll see you next week. Yep. Good night.
Good night.